Today I'm presenting you game theory, mixed strategies, probability. Not available today. I am presenting this and put to the system, then you will follow this from the recorded version. The game theory, as you are understanding, is mostly concentrated to and the probability is becoming very important in the economics and of course in the game theory. Probability is a theory which is a branch of mathematics concerned with the analysis of random phenomena. And a random event can be coming. Okay, then I will wait. Oh, if you don't come down, I will present. And then I will put the system.
Hello, Hujam. See how that is.
Huh? Hatice? Oh, I'm already started to present. You follow it, okay?
Sorry, Hujam.
Huh?
What did you say?
Started present.
Hujam, I cannot hear you.
Check my mic.
Hujam. Darling, let me earpiece because I want to pay attention in this class. I can't hear it in. That's my earpiece. Hujam. Where's my phone now? I'm paying attention. No, please tell him. She can she are cooking. You are cooking. Who is not joining us? How far?
Yes.
Hujam?
Yes, please. I'm starting
Hujam?
presentation. I'm okay. You?
How are you, Hujam? How are you?
I'm fine. You?
I'm fine, Hujam. Thank you. Hujam, when are we writing midterms? I'm fine.
No,
We are not
next
writing
week.
midterms for game theory, right? Hujam, projects better.
Um,
No, Hujam, projects better.
but I have to do one at least test. It is necessary to do the test. You understand?
Okay, how many marks?
Around
Yes,
25
I understand. How many marks?
to 30 marks.
Hujam, no, 20,
But 20
Hujam.
is not too much because I will give you not too much assignment.
Okay,
Okay,
okay.
around 25 marks for the exam
Okay.
and 25 for your assignments, okay, for your homeworks.
Okay, Hujam, exam multiple choice.
Multiple choice, yes, because we are doing
Okay.
okay, it is not difficult. I will try to make it as much as possible less mathematical. As you see, I am doing too much theory, but in managerial economics we have to do this.
Yes, I take both courses. So just Hujam, just theory, multiple choice for game theory. You know we
Yes,
like
yes,
game theory, very good course.
yes. But let me start my class. You are here, then I'm going to
Okay, Hujam.
share with anybody else. Or we start.
Um, Irene wants to join. You're not accepting her.
I
Irene,
don't know. I don't know.
Irene and
Irene.
Patience.
I didn't see
Yes.
her. She didn't
Okay.
apply to the class. Question.
Okay. He said he did not
Ask,
check.
write him to come to the class. Then I will accept it because I didn't see her.
He said he cannot see you. Okay, Hujam. I've told her.
I am starting. Okay.
Okay, Hujam.
Okay. The probability we are starting today game theory with the probability option, which is
You're,
I think
you've
somebody is
joined.
joined.
Yes,
Is
Irene.
joined. Okay. Game theory. Okay. You switch your microphone and then I go through. And if you have any question, ask me. Okay. In game theory, as I said to you, we are concentrating mostly to the which is very popular in mathematics, and we are using this for being able to understand how the payoff matrix is going to be more profitable in game theory. The probability is a branch of mathematics concerned with the analysis the outcome of a random event cannot be determined before it occurs, but it may be any one of several possible outcomes that actual outcome is concerned to be determined. Therefore, probability is very important to know before going to apply to the game theory. And probability is a numerical description of how likely an event is to occur or how likely it is that a proposition true. As you know, the probability is between 0 and 1, and where it is, the 0 indicates the impossibility, where it is the lowest value that we are expecting to be realized, the lowest proportion, and the 1 is indicating this most certainty of this probability, which is going to be realized. Probability is in the game theory very important, as I mentioned to you. Therefore, we are starting with example. For example, the statement that the probability of heat in the tossing of coin when you are throwing it up, when you're tossing it up, then you are expecting either it's going to come either head or the one half of it is going to be accepted as the probability proportion, which is 50-50. This is then, of course, means a large number of tosses that relative frequency with which this will occur will be approximately one half, and the other part is, of course, the other half, which is head or tail, is going to be realized 50-50. This is then, of course, implication concerning the outcome of any given toss that we are realizing. The probability, as you are understanding, is the fundamental ingredients of probability theory, is an experiment that can be repeated at least hypothetically or fuzzy as you are randomly and under essential identical conditions, and that may lead to different outcome on different trials. Therefore, as much as you are exercising this fuzzy probability application, you are expecting to increase your, of course, expected outcome, as we are doing in the multiple choice. As much as the question is increasing, your expectation to get more is probably increasing. It will then give you more comprehensive preferences in this direction. And the set of all possible outcome of an experiment is called as sample spaces. Therefore, this is the very important part of this probability in following section. The probability is the set of all possible outcomes. Of course, an experimental is called a sample space, and the experiment of once result in a sample space with two possible outcomes. Either is going to be head or tail when you are going to toss this coin, and you are expecting to get either head or tail. Tossing two dice has a sample space as similar with the coin. You have multiplying this with the possible numbers which is on the dice, then you have, of course, 36 possible outcomes, and each of which can be identified with an ordered pair of I or J, either or, which we are expecting with two dice that you are getting any possible I and J. Assume one of the values 1, 2, 3, 4, 5, and 6, which is on these two dice, is written. Then denotes this face showing on the identical dice, and every dice will give you, of course, different proportional combination, as they 1 to 2 or 1 to 3 or 1 to 4 or 1 to 5 or 1 to 6, or then 2 to 1 and 2 to 2 and 2 to 3 and 2 to 4 and 2 to 5 and 2 to 6. It goes like this, and you are expecting to get 36 possible toss for getting the possible combination of this probability in the combination. And of course, tossing a coin die giving an example for understanding the probability and of course impact to your of course expected payoff. It is important to think of dice as identify each as the difference in the color or such as the difference in the outcome. As I mentioned to you, 1 to 2 or 2 to 1, it is totally the same, but it is expected to get the different dice, different numbers. When the combination can be calculated as 36 times toss of these dice. For example, the sum of the faces showing on the two dice equals 6 consists of the 5 yeah, 1 to 5, 2 to 4, 3 to 3, 4 to 2, and 5 to 1. Therefore, every possible combination can give you different application if you are excluding the 6. Therefore, you have to put this combination of course probability option, then you will then get the best possible combination, which is in the end 36 times tossing of these dice is expected to realize in given scenario. Tossing coin is more simplest and more reliable example for you to understand the of course probability in the game theory, since there are two possible outcomes, 80% of each toss to get either head or tail, isn't it? The number of elements in this sample space is supposed to be 2 to n, and as much as you are increasing this toss, then this is of course enlarging and increasing. Only one outcome corresponds to having no heads, so the required probability is supposed to be 1 over 2 power of n. Therefore, every next toss will give you this much of combination between these two head or tail option on the coin. It is only slightly more difficult to determine the probability of at most one head. And in addition to the single case in which occurs, there are no n cases in which exactly one head occurs, because it can occur on the first and second and then third. It goes like this as an n toss in which we are realizing with this toss in this coin. Hence, there are n plus 1 cases favorable to obtaining at most one head, and the desired probability is supposed to be over 2 is the power of n, will give you this of course probability calculation or option. And strategic form, when we are putting into this direction to the game, of course it is the most important part of the game story, as you are
Hujam,
understanding, to estimate and determine. Yes,
Hujam,
please. Yes,
Hujam.
yes,
Can you
yes,
go back to last slide? Can you go back to
yes, I'm on the
last
last.
slide?
I am on the last. I change
No,
it.
it's not changed. No, okay,
Did you see?
yes.
I have already.
The formula n plus
It is
1,
little bit slowly
n plus
because
1
of the distances.
divided
It
by
goes
2
slow.
raised to power n.
Power n, yes, is the probability.
Is this n?
Believe.
Okay.
Okay.
What is the formula for what?
Tell
The
me.
probability of finding possibility of the coin?
Yes, you're going to
Oh,
use
that's
this
okay.
as much as is
Probability
possible.
of finding the possibility of the possible outcomes of choosing hand to
Yes,
hand.
of tossing this
Okay, continue.
coin. It can be, there are
Continue.
different kind of combination of this probability.
Okay.
We will give you, I will give you, don't worry, in the following slides, we have either that we are using for the probability or
Okay.
combination, or we have permutation also that you are going to exercise regarding to this game theory. Okay, as I said to you, the strategic game is becoming most important part, because you know that the strategic part of the game is the most important decision making, because you have to determine the most important strategy for being able to solve this understanding in the game theory. The strategy, the estimation of the strategy is dependent to your rivals. Therefore, you have to learn to manage and of course choose the best possible strategy for beating you, or by for beating your rivals. Therefore, it is very important part of the game theory. And in this direction, game theory, the strategic form or normal form, is a way of describing a game using a matrix that we are using either game tree or matrix, which we are going to use for estimating the payoff, for being able to determine the best possible outcome of given scenario. Because life is a game, and you have to learn to determine the best possible option regarding to these options that is given to you in your life. As exhibiting or exhibition of six of each side of this matrix, which is written on the combination between these two, of course, option given on this, let's say, coins, and either it is going to be either 1 or 0, or you have 0 or 1, or you have 1 or minus 1 if you are going to choose head and give it to plus 1, and if you are going not choosing tail, then you give this a minus 1. Therefore, either playing this game, therefore the payoff matrix will be realized between this 1 and minus 1, and it is, of course, 4 option can be realized because your rival is also in this scenario existing. Therefore, each strategy or choice can give us a choice or give us an option for determining between A and B, and the set of payoffs then will become, of course, realized between P1A and player 2A, or player 1A or player 2B, or player 1B and player 2A, and player 1B and player 2B. Therefore, 4 different combination options can be realized if you are considering this game on the game tree, also on the payoff matrix. Therefore, for finding the possible combination, we have to use this probability, and we have to know the probability which is given to you in the following slides for being able to understand and apply to your, of course, decision or to the payoff matrix for being able to determine the best possible option, of course, given outcomes or the payoffs. The factorial either very important, as you are understanding on this direction, which we are also requiring to calculate on the game theory, because factorial is also helping hand to calculate a combination. You will need to calculate, of course, factorial either, because the combinations dependent to this factorial is the product of all the possible or positive integers equal to and less than your numbers. Therefore, factorial is written as the number followed by an exclamation point. For example, to factorial of 4, you would write 4 factorial. Therefore, you have to calculate the rest of the numbers which is below 4. Then it's, of course, is supposed to be 4 multiplied 2 multiplied 1 will give you the 4 factorial, which is 24, because 4 times 3 is 12, and 12 times 2 is 24, and 24 times 1 is 24 again. Therefore, the factorial for the 24 times probability option in a given scenario. By multiplying these numbers, you will get this factorial as you are observing in this given example. It is, of course, calculated with the rest belonging to this 4. And when we are using this factorial in the combination, we have to determine, of course, first the factorial, and then put to this into the combination, which is also very important, the probability, because probability is dependent, or of course comprises or consists of this combination of the variables or the choices that we are using in the game theory. Therefore, when we are combinations, we are looking at the equation to calculate the combination of this given, of course, numbers, and you can see the factorials as used throughout this formula. And remember, the combination is supposed to be n combination. R is supposed to be n is the, of course, factorial divided to the r factorial is multiplied with n minus n minus r. N represent the number of the items, and R represent the number of the chosen items. Therefore, if you are choosing, for example, you are listening me. If you are
Hujam, um, Hujam,
yes, please. I'm
um,
listening.
you said n factorial divided by r factorial multiplied by n minus r factorial. So
Because
r
R is the
factorial.
chosen
So
numbers and N is the number of the items, such as the dice. If you
okay.
have six
So
numbers on the dice, then you have
so
to
if
choose one, for example. Yes, I will give you an
so
example.
if you're doing n minus, my question is n
Is
minus r
okay?
factorial is you're using the values of n minus r before you get the factorial,
Exactly.
right?
N minus R. Yes, yes,
You
yes.
have to multiply, you have to subtract, then use the factorial.
Yes, you have to first subtract and multiply it because it is
Okay,
like this.
okay.
If it is in the bracket, you have to, if it is 6 minus 3, then you have to multiply this R 3 times 3 factorial. You understand? I will give you the example in the following. You see the slide here? Do you see the slide? When we are looking to this combination, do you see the slide here? The example, we are looking to the DVD combination. You see this example? It comes probably. Okay, let's look at the example given below. There are 10 new movies out to 10 rent to this week on the DVD shop. Select 3 movies of which is offered for this week, which is 10 movies supposed to be brand newly come to this shop. And how many combinations of these movies can be selected in this combination? Do you see this example? Are you able to see this, Hatice?
Yes.
Okay,
Yes,
good
yes.
then. In this problem, John is choosing 3 movies out of 10. Factorial here is given as n factorial divided to the r factorial multiplied with n minus r factorial. Therefore, 10 combination, 10 new brand DVDs combination of 3, which is 10 is the item here and 3 is the chosen numbers. Therefore, 10 factorial will be divided to 3 factorial multiplied with 10 minus 3 factorial. Therefore, when you are doing this, then you will be 10 factorial, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will be multiplied, divided to the 1, 2, 3, multiplied, and multiplied in the bracket is of course 10 minus 3 is 7. Then you are going to multiply this 7, which is 1, 2, 3, 4, 5, 6, 7 will be multiplied, and then all together they are going to be represented in the following form. As you are observing here, the first step the need to do is of course we have to reduce 10 to minus 3, then will gives you the 7. Therefore, we are putting this to the equation. 10 factorial divided to the, of course, 3 factorial will be multiplied with the 7 factorial. Due to this application, then we have this 10 factorial, which is 10, 9, 8, which is of course 7, 6, 5, 4, 3, 2, and 1 on the top, and on the below is of course 3, 2, 1 multiplied with 7, 6, 5, 4, 3, 2, 1. You can reduce this because these are on the denominator and the numerator is similarly realized, and you cancel this 7, 6, 5, 4, 3, and 2, and 1 from the numerator, of course, denominator, which is equally the same result. And you have then the rest 10, 9, 8 divided to the 3 to 1. Then you will get the answer, of course. The easiest way to work this problem is similarities, isn't it? Then we cancel this. Then you have then, of course, the rest of this calculation, which is going to be 10 multiplied 9 multiplied 8 on the top, when you are dividing to the denominator, is then of course 3 multiplied 2 multiplied and 1 left on the bottom, so called the denominator. Then from here we can just multiply this, of course, 10 times 9 times 720, and the, of course, the denominator is of course 3 multiplied 2 multiplied 1 is going to be 6. Then you are going to divide it to 720 to 6. 120. Therefore, John knows now that the, of course, expected combination is about 120 new, of course, possibility is out of these 10 because he can choose any of these three as much as he is watching and, of course, replacing with the others, isn't it? Therefore, this is then, of course, the combination of the possible outcome of this game for the first, because after the next, then you are reducing it to the 9, and after the next, you are going to reduce it to say 8, then your combination will be realized in this direction. Therefore, this is the first possible combination between 10 output, which is the new brand DVD, is going to be chosen for 3 out of these 10 is going to be, of course, rent by John for the first week. The outcome is supposed to be 120. The probability formulas can be, of course, questioned in the given below, of course, table, which is very important to understand the, of course, combination of relationship between the probabilities. As I said to you, probability is between 0 and 1, and 0 is the, of course, minimum value, which is the lowest expected value, and 1 is the highest credential, highest possibility, which is expected to be in this game or in these options, which is giving to you. And rule of additional for the union of these two set is supposed to P is, of course, the union of A and B is supposed to be PA plus PB, and of course will be subtracted from the intersection PAB. Yes, yes,
The rule of addition, the P into bracket A union B,
yes.
is
A
this equal,
plus.
is that what is equal to PA plus
These are
PB
the two
minus?
sets, two set of union, isn't it?
So
A is a one union,
how do you get the
a set,
union?
a union. Let's say you have a one group,
Okay,
and
so how do you
one
get
group
union?
of,
Yes.
huh? Tell me. For example, you have one dice. There is on it one, two, three,
Sorry.
four, five, six, isn't it? And in the B, there is again one, two, three, four, five, six. You have two different dice and two different, of course, combination, which is started from 1 and goes to 4. The first union is supposed to be 1 to 6, and the second union is supposed to be again 1 to 6 for the B. And then you want to add these two for the two dice. You have, of course, but we have to subtract the combination, which is supposed to be 6 and 5, let's say, is in the intersection area. You understand? Therefore, you don't have to calculate these two dice or two times, then you have to subtract this
No.
intersection, which is A intersection B, is in this example that I have given to you, is supposed to be 5 and 6. Then you are, of course, subtracting these numbers, then you will get this, of course, additional form of these two unions of union.
So is that a
You
subtraction
understand?
sign or is an equal to?
It is subtraction. NIP. Union A union B is equal to P union
Okay.
or P set A plus P set B. These are summation, and then you will subtract the intersection points. You understand? The points that is common in these two, let's say, set. Or there is any set. If there isn't, let's say in this example, I gave you 5 and 6 is the intersection, in this intersection area. Therefore, you have to subtract this from this union, isn't it? You understand?
Is P a
You
constant?
don't notice unions? Huh? Tell me.
Is P a constant or it's a variable?
P is the probability. You understand? P is the probability,
Okay.
as I have
Alright,
indicated in the
Tama.
top. You understand? Let's think about it. You have 1, 2, 3, and you have 3, 5, 6. Okay. 1, 2, 3, 4, and let's say 4, 5, 6. You have two unions. Let's say I will give you the first union, which comprises 1, 2, 3, 4. You understand? You listen. And the second union is supposed to be 4, 5, 6. Which number is here as the intersection? 4, isn't it? Because 4 is both in both union, in both set is existing. Therefore, you have to both intersection point, isn't it? In the first union, you will have 1, 2, 3, 4, and in the second union, you have 4, 5, 6. Which one? Which number is the union intersection point? Is it? You understand? Therefore, 4 is the intersection point. Therefore, for the PA, you have to put 1, 2, 3, and 4. And for the B, you have to put 4, 5, 6. For the intersection points, you have to put only 4. Then you will subtract 4 because 4 is a common number for the both set. You understand?
Yes.
It's not difficult, but it is difficult because we are far away and you are not able to. I can put you an example easily. You got it now. You understand?
Yes.
Insist.
Yeah.
Or shall
Yes,
I?
Hujam. It's okay. It's
It's
okay.
clear, isn't it? It's not. It's okay, isn't it? Okay.
Yeah.
And rule of complement event for the complementary means you have to complete each other, like A and DVD to play, isn't it? Complement. Like you buy a hamburger with Coke, something like this, or you buy a car and you buy also gas or benzene or oil to drive it, something like this. Complement. Or you buy shoe and you buy socket, something like this, which is combining each other. DVD and DVD player understanding for these complementary goods. Therefore, rule of complement events is supposed to be PE dash, which is the complementary, and PA is the product. Therefore, it's supposed to be the PA is 0.6, the rest of is of course 0.4, isn't it? Therefore, these are supposed to be in the probability will be combining each other. Or in the economics, as I said to you, if you have $1 and you are consuming cent or 80 cent of this dollar, the rest of the dollar, which is 20 cent, will be saving account, will be in the saving account. You understand? Therefore, these are the complement because if the consumption for the consumption you are spending out of $1 80 cent, of course 20 cent is supposed to be is going to be for the understand? You got it? It's clear. I think it is
Yes,
okay.
I do. Yes.
Yes, and this joint, or as I said to you, intersection with, as I have illustrated in the former section, if there isn't any intersection, it's supposed to be 0. This is then of course disjoint, no intersection. Then is of course 0. And in the it's supposed to be P intersection PA intersection B is supposed to be P probability A multiplied with probability B will give you of course the result because all these variables are independent, not dependent to each other. And conditional probability is supposed to be P over PA over B is of course will be illustrated as the P or probability A intersection B going to be divided with the probability B will give you this conditional probability result. And Bayes formula, which is going to be introduced to you, that we didn't do it already, we will do in the process. Then Bayes formula will be, of course, PA over PB is equal to P or probability B over A multiplied with probability A
Mm.
will be divided P or probability B. If you have any question, you ask me, or I will go further because these are only the formula that is given to you for the
Okay.
probability. Is okay?
Hujam,
Yes, please. Yes, I'm listening.
um, when do two numbers intersect?
I couldn't get the question.
When do they intersect?
Yes,
Like when A union B is a number that is in probability
exactly.
of A and probability of B. So when it is A intersect B, what is the difference between union and intersect?
Union is a separate two groups. Fingers, you have to separate groups. You see my fingers? If you, it is an intersection points between these two, then of course you have to put this intersection into the intersection area. If you have two set of union, 1, 2, 3, 4, and 4, 5, 6, 7, let's say, the intersection point for these two separate group is the 4, isn't it? Because you are using the number 4 for the 4, you have to subtract this 4 from these two union because two union is exactly the same, but is not exactly the same, but 4 is exactly the same number in the group where we are using. Therefore, you have to put point out of this two group because you don't have to count this twice. You have to reduce it to one because you have these two group of union numbers or members with different, of course, variables of intercept. Therefore, intersection point where you have the similar in B and A must be in the intersection area. You understand? Is it clear now or not?
Yes, I understand.
Okay.
It's not difficult.
Okay. Let's look up to this example again. Brain teaser is supposed to be there are 30 people in a room and questioning the number of these 30 people's possible chance that they have at least two of them the birthday today or that day that they are in the birthday room. Of course, the easier question to answer is what is the chance to know the number of two share in given 30 people. Therefore, we have to create this scenario by using which we have done before. A given first person, any one of these probability is supposed to be, of course, since a year is 335 days, comprises 335 second person's possibility is supposed to be less than 1 is 364 days to choose from the given option, and the third person is supposed to be 363 days to choose from without having a repeat because repetition will cause a problem in the probability. Therefore, when you want to calculate the best possible solution for the people who are supposed to be a group of three people out of these 30 given a person which can be a same birthday at that day, then of course will be calculated as 365 divided 365 multiply 365 multiply 365 divided 365 is equal to 99.18 probability, which is of course option or giving you of course information about this 30 person who are in the room and is expected to have the probability out of this 30 people, which is of course yearly daytime, and this is on of course 365, and every next reduction from this group will be reduced from the year and is of course calculated as above given example. Now doing this, you have a question for being able to,
Um,
yes please. For being able to apply this for the 30
Did you
person,
assume that? Did you group?
yes, I grouped this for three
Did you
person
assume
first.
that? Did you group the?
No,
Okay,
just
I understand.
randomly,
So
randomly.
now
You
after
choose
submitting the
random,
data,
random, random selection, okay? Not certain people.
yes, I understand.
And if this is asked to you for
Yes, I
30
understand.
person,
But then,
yes. If it is asked you for 30
okay,
person, then you have to
this
calculate.
after from 365 down to 30, right? With
Yes,
sequential
exactly.
form consecutively. That
Yes.
will give you
The 30 person,
29.36.
30 person, for 30 person,
Okay.
for the below given numbers, which is
Yes, for 30.
365 over 365
You
multiplied,
your factorial.
no factorial, just
You're using
only
factorial now to get it.
calculating. No factorial here. Just only
Multiplication.
multiplication, exactly.
Okay.
You just
Okay.
less one
Tamam. So
day
where did you get
reduce.
the 100%
Every
from?
next person you have to reduce one day because we have 30 person here and
Yes, I understand.
each person's possibility is going to be one, isn't it? Therefore 30 to 35, 300,
I
yes,
understand.
365 divided 365 multiplied 365 divided 365 multiplied
I understand.
365 divided 365, it goes like this: 337 divided 365, and then 336 divided 365, because you are reducing
Okay.
every next person one
So
day, and at the end you will have
okay.
29%
Okay,
36 for the probability of these two
I
possibility. You
understand.
understand? And the probability for that day is of course 100% minus 29 multiplied 36, then will give you this 70.63. Of course, this is of course another option. If it is asked to you which one, what is the percentage of these people who are not having birthday at that day, is of course 70.63, and who person out of this 30 person who has possibility to have the birthday is 29. This is of course the two people's option given in this scenario. Is okay? You understand? Is it clear?
Yes, it's clear. We can go to the
Probability. You
next slide.
understand this? Yes, this is then of course the
Yes, I
formula that we have
understand.
done. We have used this given example here in the former example, for the teaser example, for the birthday example. To probability of an event occurring, we will use the formula as I have indicated in the former example: the number of favorable outcomes divided to the number of total outcomes. Therefore, this will then give you the possible as it is given in the former example. You dividing it for the first person 364 to divide it 365, or 363 divided to 365. As many numbers, then you will get the probability option as it is given in the example. Let's look to the next example, then you will understand better probably. We have an example, as I said to you, to calculate the probability of an, of course, DVD, which was given in the former with the numbers. Now we are giving the colors. John supposed to purchase a bag of gumballs, and in the bag of gumballs or balls there are 5 green or 4 white and 8 yellow gumballs or balls. What is the probability that John, drawing at randomly, of course, casually, will select a yellow gumballs? This is yellow. Then we have 5, 3, 4, and 8. Therefore, you have to calculate first the amount of the items. And when you are looking here, when you calculate this, we balls, and of course the yellow, which is question, is 8, isn't it? As it is given here, we have yellow, which is 8. And when you are yellow, you have to do the given formula. The number of favorable outcomes will be divided to the total number of outcomes. Therefore, the calculation will be realized in the direction of this formula for estimating the outcome as it is given in this example. You see here the probability is given. The Jones possible, of course, probability which is given in this scenario. He adds all the gumballs together, which is 20 gumballs, and in the back there is of course 20 balls. The number of total outcome is supposed to be 20. John also knows 8 yellow gumballs or balls, which would represent the numbers of favorable outcomes. So the probability of selecting a yellow balls at random from the back is 8 out of 20. We have to calculate this probability from this favorite, which is going to be divided to the total items, then is of course is 8 over 20 will be of course reduced to 2 to 5, because there is 4 times 5 is 20 and 2 times 4 is 8. Therefore 2 to 5, 2 over 5 will give us the equation. Then this is then of course 0.4 is supposed to be the probability of getting a yellow gummy or gumball from the back at randomly selected procedure. You understand? And here is of course the probability is 0.4. Yellow is then of course 0.6 can be estimated, can be suggested without hesitate, because since the probability between 1 and 0 or 0 and 1, the rest of the 0.6 is supposed to be probability of yellow gum balls. Another example for giving the probability that of course given is of course is the ace. Total number of cards supposed to be 52, isn't it? And when you are expecting to get ace out of this 52 is 4, because we have 4 ace in every set of and as you are understanding, since 4 card is supposed to be or will be ace, the rest of the of course card is not going to be ace, and the number in the deck is supposed to be 4, and the number of favorable outcome is supposed to be 4. And from this direction, the of course formula that we are going to use again, the favorable outcomes and the total number of favorable outcomes will be divided for being able to estimate and calculate the probability of given example. And 4 over 52 was simplified to 1 over 13, and this will give you of course 0 point some 2 or 3, and which is going to be very lower proportion. And when we are calculating the probability of getting an odd number if a dice is rolled, when your dice is 6 numbers written, 1, 2, 3, 4, 5, for being able to expect the number of dice on this, of course, to become or to being able to come is supposed to be 6. And let's be an odd number supposed to be, isn't it? 1, 3, and 5 is the odd numbers, and the number of odd numbers, since it is 3, and the number of total item is supposed to be, which is 1 to 6, is of course 6. Then you are going to calculate the outcomes, favorable outcomes so-called, will be divided to the total number of outcomes or items is 3 over 6, then is over 1.1 over 2, which is going to be 0.5 as a result real probability option in a given scenario. Of course, when we are having this permutation, we are using of course for the probability and of course combination either, and this permutation is also very important for calculating the application in mathematical aspect to determine the number of possible arrangements in a given set. And when the order of the numbers, of course, is a questionable, is a matter for us. Therefore, common mathematical problem choosing any or only several items from a set of items with a certain order can be P n k, which is n is the number of elements, because k is the selected items. Therefore, the permutation can be calculated n factorial divided n minus k factorial. You have question,
Hujam?
please? Yes.
Yes, this permutation nk, that is n factorial
Yes.
divided by n minus k factorial. If you're getting the
Exactly, as
permutation
we did
of
in the
nk,
combination.
the nk in the brackets, yes, in the combination, are you multiplying it, or is going to
Of the
become,
items,
for
and
example,
k is the
permutation 3
selected
5
items,
equals to 3
preferable items.
factorial? So you
Yes,
don't
yes, 3
multiply.
5.
You don't multiply. You just
No,
write
no,
it
no,
that
no,
way.
no, no, no. Just subtract it and then multiply. Yes, and multiply. Permutations, of course, we have to factorial.
Okay.
Use the factorial.
Uh-huh.
Okay. Okay. Let's look the example here. You are a partner of private equity firm. Top 10 private equity firms supposed to be, you are in top 10 private equity firm in the world. We are, of course, questioning. Our list of the top 10 largest private equity firms is supposed to be sorted by total capital raised, and of course common strategies within this private equity. You want to invest, of course, 5 million in two projects instead of equal allocation, and you decide to invest 3 million in the most promising project and 2 million in the promising project. Therefore, you have two options, either the most promising or less promising. If it is most promising, you will invest 3 million, sorry, and if it is less promising project, then you will invest 2 million, because you have total more than 5 million dollar in your let's say portfolio, and you want to invest to know, of course, which is the best possible option. You analyze shortlisted, of course, you have out of this project which is given to you will be reduced to 6. Therefore, you have now 6 to being able to choose to invest in the direction for being able to become more profitable as much as possible. How many possible arrangements are available for you? Investment decision is questioned now in this given scenario. The permutation, of course, now in the subject, the example which is given, we require to apply the permutation, of course, the factorial, for being able to estimate the possible, of course, outcome of these two options. And since the allocation of the money is two direction project which is offered to you is 6, then you have to apply this permutation in this direction and in this formula with the permutation out of 6 to 2. Therefore, project evaluation review technique in this is used to identify the time taken for finishing this, of course, task, being able to become more profitable in this business. It is not equal, as I mentioned to you, the selection order or item. And due to this reason, you have to consider the following arrangement. Investing 3 million project A, and of course 2 million in project B, or vice versa, investing 2 million A or 3 million in a project B, vice versa. As I said to you, this is required to be solved in the matrix formula and matrix concept. The options are not available, therefore we must use the formula above to determine the number of available arrangements. Which is given here. The project A is supposed to be 3 million and the project B is supposed to be 2 million. We have, and then of course similar, the project A is supposed to be 2 million, will be of course yielding, and the project B will be of course 3 million as it is given in this option. And the combination permutation is supposed to be 3 to 2, and 6 permutation factorial will be divided to the 6 minus 2 factorial and 6 factorial divided to the 4 factorial will be then equal to 30. This gives you the best possible option in a given scenario. Do you have any question? I think you collapse. Some people collapsing. And permutation to estimate the probability can be used for the pin codes. You are listening me, Quentin? Permutation and combination to estimate the probability. We are using, of course, the permutations and combinations to answer more complex probability questions. Let's suppose the pin code for the mobile, we have 4-digit numbers. And what is the probability of these 4-digit numbers can be chosen out, which is possibly is going to be used for estimating the pin code for using, isn't it? Hatice, do you have any question? You have question?
Who jam? Somebody pushed me out of the group chat. I don't know who. Somebody
I
pushed
didn't do
me
anything. I
out.
just,
I don't.
I know last lecture I had also similar problems, but I hope you will not,
Okay.
you will, do you
I
have me,
understand. No problem.
do you want me to go
Yes, I
back
understand.
to, do you
No,
want me
no,
to
no,
go
no, no. I
back?
understand. No, I understand. Just
Now the
continue.
Quinton pushed, I think. Okay. Okay, and the permutation and the combination to estimate the probability, we can use, of course, as I said to you, this permutation and combination to help to answer more complex probability to you. We are using this pin code scenario for being able to apply to the, of course, mobile. And since there are 10-digit numbers, we have, of course, the possible by using 10 multiplied 10 multiplied 10 multiplied 10, which is 10 power of 4, then will gives you 10,000 possible option for this, of course, pin code, isn't it? Therefore, you have then 10,000 possible option or combination for getting this 4-digit pin code number in a given scenario. Therefore, permutation now is going to be used in this direction with the formula of 10 power of or x power of n, which is x is here the, of course, selected numbers or selected variable, and the power of is going to be represented as n. The strategic form of game is, I think I can stop here, and next lecture we will go on because it is going to be a little bit complicated now. I can stop here. The next lecture we will go on. Is that okay? Because because we have too many applications, then I think
Okay,
you have
Hujam.
to
It was a good
exercise
lecture. Today's
this
lecture was good.
permutations, combinations, all, and then I will apply this because you need to exercise at home, isn't it? Is that okay?
Yes, Hujam. For the midterm exam, is
Yes,
it from the
until
beginning of the semester
permutations,
to
then
what we
I
did
will let
today?
it here. The next lecture after the exam, I will then put you to your okay, because I don't want to go further since your colleagues are not here.
Okay.
I think it's enough for
Okay,
today.
Hujam.
Then after next week, then we will have.
Okay, Hujam. It was a very good lecture. I
Thank you very
understood very
much. I
well.
am happy.
Okay, Hujam.
You were okay.
Okay. Okay, Hujam. I
Okay.
am
Thank
happy
you. Bye
too,
bye.
Hujam.
Thank you. Bye bye.
Yes, Hujam.
Bye bye.
Okay, Hujam. Bye bye. Bye.